This video is on Chapter 3, Segment 2, which was pages 81 to 87. The chapter first began talking about autoshaping in pigeons, and autoshaping is the first systemically invested example of sign tracking. Brown and Jenkins got a group of pigeons to learn how to peck plastic disc on the wall when they wanted food, and instead of shaping the response by reinforcing successive approximations, they illuminated the key for 8 seconds and then gave the food to the pigeons. The birds began pecking when the key was lit, and the food was presented whether or not the birds pecked. It was almost as if they couldn't resist pecking. And autoshaping with pigeons is used for investigating how animals associate signals with food. Autoshaping develops in about 40 CS to US pairings, and pigeons learn to associate the key light with food when food is presented as much as 6 to 12 seconds later. The next section talks about taste aversion learning in rats. And rats will reject a flavor that is associated with the injection of a drug that makes them feel nauseous. And the CS was the flavor stimulus, and the US was the drug injection. And under the right conditions, a strong aversion can be learned after only one conditioning trial. And aversions can be learned when the CS and the US are separated by many hours. Understanding taste aversions can allow researchers to understand how animals come to select and avoid certain foods. And an example in humans is taste aversion to cancer patients that are undergoing chemotherapy. The next section talks about things that affect the strength in conditioning, and those are time, the novelty of the CS and US, the intensity of the CS and US, and the pseudo-conditioning and sensation. So the first one, time, talks about how conditioning works best when the CS occurs before the US, and the CS signals that the US is about to happen. The book talked about delay conditioning, which is when the CS comes on and then ends with the presentation of the US. The amount of conditioning will decrease if the interval of the CS onset and the US onset exceeds some value. Next, it talks about trace conditioning with timing, and this is when the CS and the US are separated by a gap or a trace interval, and this follows the idea that some neural trace of the CS rather than the actual CS is paired with the US, and the conditioning gets worse when the trace interval increases because the animal might forget that the CS is related to the US over a longer gap of time. The next part is intertrial interval, and this is a second stimulus being presented during either the trace interval or the interval between the trials, and either stimulus will increase the conditioning that develops to the CS. The third way to arrange the CS and the US in time is to present them both simultaneously, which is called simultaneous conditioning, but this is believed to yield weak conditioning because the CS does not signal that the US is about to occur because they're occurring at the same time. Backward conditioning is when the CS follows rather than precedes the US, and the backward procedure usually does not produce as much conditioning as the forward pairings. If the CS signals anything, it would just signal that the interval before the next trial. Space trials is also involved in timing, and the conditioning is better if the conditioning trials are spread out in more space trials than if they occur closer together in time, which is massed trials procedure. The learning requires that the subjects rehearse the CS and the US together in the memory for a while, which is why the space trials work better. And a new trial could interrupt rehearsal of the last one if it occurs too soon. And the success of conditioning depends on the ratio between the time between trials and the time of the CS. So the second thing that affects strengthening of conditioning is the novelty of the CS and US, and conditioning occurs most rapidly if the CS and the US are new to the subjects. And this makes sense because exposure to either stimulus before they're paired can interfere with learning. So pre-exposure to the CS can interfere with conditioning, which is called latent inhibition. So for example, if you were exposed to a ringing bell, you would first pay attention to it, but then your attention would decrease and you'd become habituated to it because of the pre-exposure. And and it's necessary for an attention response to the CS for conditioning to occur. And when you're pre-exposed to the US, it's called US pre-exposure effect, and this is when habituation can also occur. So both latent inhibition and pre-exposure to the US can occur in real life, such as when a person is less likely to associate familiar stimuli to some traumatic event rather than new stimuli to a traumatic event. So they're more likely to develop fear if it's a new situation for them. Next is the intensity of the CS in the US, and conditioning is better when the US is more intense and the strength of the conditioned response is stronger. So the intensity of the CS is important because a quiet noise or bell is less effective than a loud one. So noise, loud or quiet, brightness, etc. Can be especially attention grabbing. However, there are limitations to the intensity of the CS. You wouldn't want to frighten your subject. So, for example, trying to have a dog salivate in response to an extremely loud noise would only frighten the dog, and the stimulus would be too intense. The last thing that affects conditioning is pseudo-conditioning and sensitization. So the CS can elicit responses of their own, and this can complicate how one interprets the results of the conditioning experiment. So the problem is important if the CS naturally elicits a response that looks like the response that's supposed to be conditioned. So for example, if presenting a light caused the subject to blink its eye before any conditioning, it'd be difficult to separate the natural blinking from the conditioned blinking. So with pseudo-conditioning, that's an increase in responding to the CS that might occur because of mere exposure to the US. So for example, if you're in an experiment where you get a puff of air in your eye, you would naturally blink more when exposed to other stimulus such as light or anything that might be sensitive. And sensitization is an increase in responding to the CS that can occur because of mere exposure to the CS. So an example, you might be more inclined to blink more and more to a flash of light because you've already received the flash of light before. So experimenters can use control groups to help reduce the concerns of pseudo-conditioning and sensitization, and they recognize that pseudo-conditioning and sensitization are also possible with the taste aversion with children receiving chemotherapy, which was discussed earlier in the chapter.